sketch the graph of the function f of x equals the quantity x minus 2 over the quantity x squared minus 4. The first thing we do for this rational function is to factor this completely. We can't factor the numerator x minus 2, but with the denominator x squared minus 4, we can factor this as x minus 2 times x plus 2. But then there is a factor of x minus 2 on the top, and the factor of x minus 2 at the bottom. We cancel this out. We end up with 1 over x plus 2. When we cancel the same factor on top and the bottom, we need to keep track of this. The same factor on the top and the bottom will give us a whole at x minus 2 equals 0, or when x equals 2. What this means is that even though we now obtain a new expression for the function f of x, 1 over x plus 2, but when x equals 2, we need to not include the value for the function because the original function is not defined when x equals 2. Notice that prior to factoring and canceling x minus 2, if we were to plug in 2, then we would have in the denominator 2 squared minus 4, which is 0, which is not good. And so 2 is not included in the domain. And that is why, even though 1 over x plus 2 is okay at x equals 2, but again, with the original function, the function is not defined at x equals 2. And so what do we do with this? We would graph the new function 1 over x plus 2. This function 1 over x plus 2 is not defined when x equals negative 2. And so when x equals negative 2, there is a vertical asymptote. And then we see that 1 over x plus 2 is simply the transformation of 1 over x, but it is shifted to the left 2 units. And so the graph looks very similar to the graph of 1 over x, but again, it is being shifted to the left 2 units. Now, there's one more thing that we need to do in this case is, again, we know that we cannot use x equal 2. What this means is that when x equals 2, there will be a hole on the graph. We need to clearly put the open circle at x equals 2 on the graph to indicate that the function is not defined at x equals 2.